In this podcast, we're going to look at reaction quotients. All right, a reaction quotient is basically present for some time, which we'll define as t, when the system is not at equilibrium. The reaction quotient Q will take the place of the equilibrium constant K in the equilibrium constant equation. Okay, so you still have the same reaction that we used when we talked about equilibrium constants, but now instead of this being equal to K, it's equal to Q. So when we're not at equilibrium, we'll call it Q. When we're at equilibrium, we'll call it K. All right, so what is Q going to tell us? Well, Q is going to tell us, in relation to K, some different things about the position of the equilibrium. So once we get Q, and we compare it to our K, if the Q is equal to K, then we know that the reaction is actually at equilibrium. If the Q is greater than the K, then we have too many products, which means we need to shift our reaction back to the left and make more reactants. If our Q is less than our K, that means we have too many reactants. We need to shift the equation to the right to make more products. Here's an example, okay? So it tells us that our K is 6.0 times 10 to the negative second. Wants us to predict the direction the equilibrium or the system will shift to reach equilibrium, giving the following information. So first off, we need to write the expression for Q, okay? So we've got products divided by reactants. So here's our product, raise it to the second power because of that coefficient. And then our reactants, we have H2, raise that one to a 3. And then we have N2, and it just gets raised to 1. All right, now we need to actually get our value for Q. So we're going to plug in all of these numbers. So we're going to have 1 times 10 to the negative third, and we got to square that one. And that is going to be over 2 times 10 to the negative third squared, cubed, times 1 times 10 to the negative fifth. All right, so we're going to work that out on top and bottom. All right, let's see. On top, I got 0.002, and on, oh, I lied to you. I didn't get that on top. My bad. Read the wrong line. All right, on top, I got 1 times 10 to the negative sixth. And then on bottom, after I multiplied them out, I got 8 times 10 to the negative 14th. Then I divided those, and my final answer was 1.25 times 10 to the 7th. Okay, so now I need to compare my Q and my K. So my Q was 1.25 times 10 to the 7th. And if you remember from the beginning of the problem, my K was 6.0 times 10 to the negative second. So at this point, my Q is larger than my K. It's bigger, which means I have too many products. Okay, so I'm going to shift to the left and make more reactants. Okay, and that's all you have to do to evaluate your equilibrium system using Q.